When you think about what you guys are building with this mobile phone decentralized network, describe how this works and why are phones right now not used, but you guys think is an opportunity?
Just like the Bitcoin network with compute and software is capable of providing to humans a alternative financial asset, you should also start thinking about what can we do to basically offer the service of compute to everyone, regardless of where they're located. And it turns out that mobile devices really excel at security, and they are literally everywhere, right, in everybody's pocket.
What's going on, guys? Today we've got an excellent episode with Alessandro De Carli. He is the co-founder of Acurast. They are going after a very ambitious project. They want to take this, your cell phone, and they want to get as many devices onto a decentralized network so they can use the computational power of the cell phone to be able to do all sorts of different types of work. I got no clue if they're going to be able to do it, but already talking to Alessandro, it is clear that there are major changes happening in computational infrastructure. We saw it with Bitcoin, the greatest computer network ever created in the world, completely decentralized. Now these guys, they want to use your cell phone to be able to do it. It's pretty interesting. I'd love to hear what you think when we get to the end. Here's my latest conversation with Alessandro De Carli. Alessandro, I thought a great place to start this conversation is the Bitcoin network is the strongest computer network in the world. If you take Google, Amazon's AWS, Microsoft Azure, and you put all that computational power together, the Bitcoin network would still be 100 times bigger than those three put together. And so it seems like that network really got built on the idea of decentralization. That's why it's so resilient. But it also is this decentralization plus computational power. Talk a little bit about where you guys see the Bitcoin network and this decentralization, and how replicable is this to other areas in computation?
Yeah, absolutely. So thank you very much for having me here, Anthony. The Bitcoin network, I got introduced to it in 2015, actually. And one of the things that really amazed me is that people can get organized around this topic just by utilizing software, right? Just by specifying rules. And what you're now mentioning is the massive scale that it managed to basically compound over years. And all of this compute now is securing this payment network that allows you to store value, but also just do payments globally. And I think that's another aspect of these decentralized technologies that is really important to highlight, because basically once they start and they start also offering a valuable service, they become unstoppable. And they overgrow everything that is centralized and also offer way more resilience than anything else out there.
When you think about these networks and as they get built, one of the interesting things about Bitcoin is there's no board of directors, there's no CEO, there's no marketing budget, but there is this economic incentive as to why miners would come online and help build the network. On top of that, you have the node operators. Those node operators are obviously incredibly valuable in terms of defending the network, propagating messages across the network, and allowing people to have access to Bitcoin and really understanding what's happening on the blockchain. Do you need three different kind of groups like that? You kind of have the software developers, you have the miners, you have the node operators. Is that the blueprint for building these networks going forward? Or will there be other ways to build these decentralized networks that maybe don't have to be so complex and intertwined as having three groups like the Bitcoin network does?
Well, I do think that decentralized systems, especially if they become global scale, like the Bitcoin network, they necessarily will also have some sort of complexity. But one group that you have not mentioned, which I believe is one of the most important groups that basically made sure that the whole thing started, is the ideologists, right? People that understand that this is indeed something different. This is indeed solving a big problem and offering to humans an alternative, and really believe as complete outsiders that this is the way to go. And it's only because of them that ultimately people will be able to start offering that kind of resources that are needed for that network, the miners and so on and so forth. Today, I believe that many of the very, very large miners still believe in those ideological statements, but the main driver is the incentive, just like you're saying. But the incentive was not there in the very beginning because Bitcoin was worthless, right? It was just an idea, and it's only after a certain amount of time of hammering into people that this makes sense and you should start participating, and it may become really, really big as it did. It's with that idea that then the whole network starts making sense.
You've previously said that compute is invisible yet everywhere, powering every website, every app, and every agent. And it does feel like this is the groundwork for artificial intelligence, obviously Bitcoin, many other things. Is this thing that is very physical in nature? It's taking energy, it's got hardware, and it's creating economic value. But to the everyday user, it is invisible. And so it's kind of this weird dynamic of like, it feels like magic to the consumer, but obviously the people who are building this stuff, the people who are operating in it, they understand the complexities and the difficulties in terms of building this stuff and scaling it globally. Talk a little bit about that, like invisibility to the consumer, and will that continue to be the case?
I mean, look, that invisibility becomes very, very much visible when you start realizing that your prompts with ChatGPT basically are enough to heat up an entire bathtub. So much energy is being used for just answering you about or rewriting your email, right? So I do think people start realizing the impact of this compute. I also do realize that maybe there is a difference between countries that have a very high level of infrastructure and countries that don't, because these data centers ultimately require huge amounts of infrastructure before you can even start building them. And this starts with the whole energy discussion, right? So you're talking about infrastructure projects that can take up to 20 years, right? So that ultimately you're able to start offering all the services that this modern economy is now getting used to. And I do believe that people start seeing more and more of this. The other way how this becomes visible, and this is a little bit also where we are currently focusing on, is when you open your drawer and start seeing all these mobile phones that you're no longer using. Those are just machines that have by now a lot of computing power and are basically just completely unused, but very, very much visible, right?
When you think about what you guys are building with this mobile phone decentralized network, describe how this works and like why are phones right now not used, but you guys think is an opportunity?
Well, I think that just like the Bitcoin network with compute and software is capable of providing to humans a alternative financial asset that allows them to store value regardless of where they are in the world and to transfer that value. You should also start thinking about what can we do to basically offer the service of compute to everyone, regardless of where they're located. And this is not a new narrative. I mean, this has come up over and over again, this idea of offering decentralized general compute. But what I believe that was basically missing is that you need to rethink from the ground up if you want to offer such a thing. So what I mean by that is Bitcoin cannot just be built with data frames in banks. So they needed to rethink this from the start. How can you basically create a network that allows synchronization globally and so on and so forth in a decentralized way? And the same thing is also true for decentralized compute. So you cannot just house your whole decentralized compute network in data centers where basically you have this concentration and centralization. And because my background is in mobile security, I realized that one of the foundations is actually security. So security usually is very much boring until it isn't. But in this specific case, it offers you two properties that are an absolute must when talking about a general compute network. And one of them is verifiability. So knowing that someone is actually really offering you the compute that they say they are offering you, and also knowing that they are actually executing what you're asking them to execute. And the other thing is confidentiality. So for this to really take off and people to think about using a decentralized network as an alternative, we cannot even think for a split second that they will be using this if the counterparty can inspect all of the data and can tamper with that execution. So basically, this is the foundation, right? This security aspect. And it turns out that mobile devices really excel at security. They offer some of the most advanced hardware security modules out there, and they are literally everywhere, right? In everybody's pocket. They're also the reason why you can do things like mobile banking and so on and so forth. And with this in mind, we started this project, mostly from the security angle, but we then realized, wait a minute, the vast majority of compute is actually printed in silicon into mobile devices every single year. So this is a common misconception of people that think, well, where is most of the compute? It should be in data centers, but that's simply not true. The vast majority of compute is inside your household, is inside your pockets in form of mobile devices.
Well, when you think about these mobile phones, right, you're talking about security. That security that these phones provide, how much of it is you're creating almost like a mesh network, type thing on a local level? So I've got to be in general proximity to other devices versus this could be global. My phone could be connected to somebody else's phone that's in another state or another country or something like that. Like, how do you think about, like physical proximity of devices and the importance of that?
Right. That's an excellent question, actually. So on our network, the devices become really much aware of whether they're in a local network where they can see other devices as well and can form a cluster to offer more high performance compute, or whether they are talking to each other over the internet, right? So I think it's really important that concept is there from the start and can be switched, right? And let's not forget, mobile devices are actually connectivity heroes, right? They have so many ways to communicate with the outside world, like almost no other hardware.
And now when you think about the business behind this, talk a little bit about the economic incentive for devices to participate. What is the kind of network getting out of this? What are the people who are using it? Where does economic value come from? Just talk about kind of the flow of those incentives. Today's episode is brought to you by Bitcoin IRA. Are you a crypto investor with a retirement account, but don't have any crypto in your retirement account? Listen up, this is for you. Bitcoin IRA is revolutionizing the way Americans save for retirement by helping smart investors diversify their savings with access to over 75 cryptocurrencies. With world-class customer service, military-grade encryption, and a vertically integrated licensed trust company, it's no wonder more than 200,000 Americans trust Bitcoin IRA to secure their financial future. Get started. It is quick and easy. It takes just 3 minutes to open an account. Once you're set up, their team of IRA specialists will reach out to guide you through every step of the process. Whether you're transferring an IRA from a legacy bank, rolling over an old 401k, or starting fresh with a new contribution, the Bitcoin IRA team is here to help you get access to real crypto in your retirement account. And here is the best part. As a Pomp podcast listener, you can earn up to $1,000 in rewards when you add funds to your account before tax day. Search for Bitcoin IRA in the App Store or visit bitcoinira.com/pomp to join 200,000 Americans on their journey to upgrade their retirement. That's bitcoinira.com/pomp to upgrade your retirement today. Today's episode is brought to you by Zappo Bank, where eligible members can unlock the power of Bitcoin without selling it. Need cash fast? With Zappo Bank's Bitcoin-backed loans, you can access 40% of your Bitcoin's value, borrowing as much as $1 million for a full year with low interest rates, zero fees, and no early repayment fees either. Now, here's the best part. You keep your Bitcoin, meaning you get to watch your holdings grow as the price of Bitcoin increases. Whether you're looking to buy a house, fund your child's education, or seize an exciting investment opportunity, these loans give you the flexibility to access cash without selling your Bitcoin. Unlike traditional loans, Zappo Bank's Bitcoin-backed loans have no minimum repayments, no early repayment penalties, and the flexibility to settle your loan in USD or Bitcoin whenever it suits you. It's liquidity entirely on your terms. Zappo understands the unique needs of Bitcoin holders. That's why they have developed a product designed specifically for you. With over a decade of experience in the Bitcoin space, Zappo Bank has been a trusted partner for those looking to make the most of their Bitcoin while keeping it safe. Your Bitcoin stays safe in your vault, untouched, never lent out, and secured in a global network of military-grade bunkers with cutting-edge security technology. Head to zappobank.com/pomp to learn more. That's XAPOBANK.com/pomp. Go check them out at zappobank.com/pomp today. And now when you think about the business behind this, talk a little bit about the economic incentive for devices to participate. What is the kind of network getting out of this? What are the people who are using it? Where does economic value come from? Just talk about kind of the flow of those incentives.
I think that to be able to talk about value, we need to start talking about the cost structure for providing and bootstrapping compute. So if we compare this now to a traditional model where we have a server sitting in a data center, first of all, you need to make sure that you have the infrastructure to power that data center. So that's quite a high cost. But let's assume you just take that for granted. You will need to build the data center. And then afterwards, you house that server, you need to buy those devices and so on and so forth. Now, mobile devices have a very nice property that whenever they have some sort of malfunction, people look at them as pretty much worthless. This means on the other side that you can, with very little capital expense, start buying a lot of compute, a lot of valuable compute. Like these devices have 8 cores and 16 gigs of RAM by now, for really not that much money, right? Something that would cost you way more if you want to have the same amount of compute in a form factor of a server, ultimately. And the other thing is as well, these devices never had the privilege of being connected 24/7 to a power supply. This means that if you take the operating cost, they're also way, way lower because the chips that they have are way more efficient at providing the same level of compute and consuming way less power. So by offering a cost structure that is way lower, you can actually overcome the overhead that you will face from things like decentralization. Because let's not forget, if you want to offer a really reliable service, obviously you will need to be able to work with multiple replicas. And all of that adds to the overhead. And ultimately, if you're not utilizing mobile devices to offer this service, the overhead will be larger than whatever is there from a centralized perspective.
In these networks, what are the risks that of what could happen? Like, how do you think about where could the network fail? Where could people who are using it not get what they think they're getting from it? Explain that a little bit.
I mean, obviously, you have a lot of risks coming also from the technical side. I mean, bugs are still possible. Also, while these devices are very, very secure and have all sorts of security bounties paid by the manufacturers, they still can have some sort of security flaws as well. All of that you obviously need to take into consideration. And then I do think that you need to work with incentives. Because one of the biggest risks that we've seen now with running our testnet for over a year is the risk of someone just basically unplugging the device entirely so that the other party wouldn't receive the compute that they expected they would, right? And the only way how you can solve that is by setting the right incentives and by basically saying, if you say that you're going to provide compute and you get paid for it, there will be a penalty if you are no longer doing what you were saying. And this is also where these decentralized systems actually excel at. Yeah.
Do you need partnership or participation from the hardware manufacturers? Apple spends a lot of money on R&D. Obviously, Android, there's plenty of devices that support that operating system. Xiaomi, I mean, there's just, you go around the world, there's people, Samsung, et cetera, that are all creating these products. Do you need them to participate, or can you basically just let them go and innovate, and then you're coming off the heels of them without their participation into building these networks?
Yeah, absolutely. So it is the latter, right? We are basically utilizing the device as it comes, completely unmodified, because as soon as you start modifying it, you lose this integrity protection that is so important from this hardware security module. And we basically just created a protocol that can accommodate devices from all various manufacturers, as long as the manufacturers will create a so-called attestation of the hardware. So if they create this attestation, we know that the device is completely genuine, and we know that it is functioning the way we expect it would. And by simply having that, we can then build on top all of those rules that are so important to be able to provide this general compute. And what you're highlighting here is basically the superpower that we have, right? If you take a look at Apple, they are making 2/3 of their revenues from the iPhone alone. So not the iPad, not the iPad and the Mac and iPhones. No, just the iPhone alone makes 2/3 of their revenue. They invest 33 billion in R&D every single year. So all of this R&D budget, a big portion of that is basically flowing into making this the best possible device. You cannot match that as a small startup. You basically need to use that unfair advantage of just piggybacking on top of that excellent engineering. And if you think about it, it's crazy, right? People just throw them away after 2 years because they get bored from the hardware or because the new device comes out. And all of those engineering hours and all those engineering expenses that have been put into these devices to then just being put in a drawer. And basically now you can just start saying, okay, this is very valuable compute. Someone else can use that while I'm no longer using this device. Let me just onboard this to a decentralized network, right? And I think that's the real beauty here, because also other people can start creating businesses around this, right? Working with secondhand phone dealers, where they say we now start buying them in bulk and start institutionalizing the whole process. Very similar to what happened to Bitcoin, by the way, right? People started by just letting this software run on their normal laptops and desktops back then. Then at some point they realized you can optimize and there is an edge if you do. And now all of a sudden we have a very, very super professional setup of these devices. But you can still participate also with a CPU if you want to, right? You will just not get all of those efficiency gains that people got throughout the years.
When you think about what people will do with a decentralized network of mobile phone kind of compute, what are some of those things that you expect people to do? What's going on, guys? I hope you're enjoying this episode. Before you continue, I want you to know about a brand new show called From the Desk of Anthony Pompliano. I sit down at my desk every single morning and I explain what I think about current events. It's a great show that hopefully will keep you informed and entertained to a little bit. And so if you go all the way over to the other channel, From the Desk of Anthony Pompliano, on YouTube, Rumble, X, and every other platform, From the Desk of Anthony Pompliano is a show that'll keep you informed about all things financial markets, general business, pop culture, and of course, Bitcoin. I'll see you guys over there. Now let's get back into this episode.
One thing that these devices offer you is confidential compute, basically, because of this chip that I'm now mentioning over and over again. You can basically leverage a thing called trusted execution environment that makes sure that whoever is running the device for you is incapable of inspecting whatever it is that you're giving and sharing as data. So what we offered as one of the accelerations of the environment that people can use to deploy things is basically an LLM acceleration. And what this translates to for a consumer is that you can run your own confidential ChatGPT on Acurast, while you're 100% sure that the other party is not capable of reading all of the context and data that you're sharing with it. This is one of the popular use cases. But we have over 10,000 deployments already, and people are using it basically for all sorts of things. Some people are using it to scrape data because you do have a lot of various entry points from the consumer side of you, right? You don't have these data center IPs, so the way you're able to observe the internet is just through the eyes of the consumer. This is very, very valuable to them. And yet another example is also one protocol is utilizing this to wrap and unwrap native Bitcoins, basically running a Bitcoin wallet inside this trusted execution environments, and by now already holding more than 900 Bitcoins on chain.
And then when you think about these businesses that can get built on top, obviously it will start with, kind of independent developers or small companies. Is the goal to eventually get such a big network and it be so decentralized and so kind of large that eventually Google or Amazon or one of these big large companies could actually go and run products on top of it? Or do you think of this decentralization as something that is for kind of smaller compute use cases?
The reality of things will be that in the beginning, people will start utilizing this for non-mission critical things, unless there is no other way to do it. For instance, this Bitcoin example that I gave, there is simply no other way to do that because the simplicity of Bitcoin actually is limiting you in what you can do from a programmability perspective. But I believe that most of the cases will be non-mission critical to start with. But as the network grows, and that's another superpower of this network, is that it can grow globally in areas where usually you don't have compute, and make that compute very much accessible locally, right? And I believe that that will be leveraged more and more. So at the moment, it's mostly ideologists that are utilizing it, plus people that realize that the compute is actually super, super cheap and you don't require to change your whole code stack to deploy those workloads, because the Acurast environment is actually running with something called Node.js, which is the #1 framework for developers. But yeah, I think the ambition definitely is that this becomes the most accessible global compute network out there, period, right?
And then when you think about your role in this, other people on the team, like what is the expertise? What's the knowledge? What's the experience of people that you need? Because there's hardware, there's decentralization, there's obviously software, there's business, there's strategy. Like there's a lot going on into something like this to make it work. That's probably the reason why no one's been able to make it work before. So how do you guys think about the skill sets necessary?
Yeah, this is a little bit where the background that I have and also other members of the team have comes into play, because we started off. So my CTO and I started off in Credit Suisse in basically the very same team, and we were leading the mobile security for all of the banking apps. So be it the mobile banking, but also the relationship manager and so on and so forth. We soon realized that this knowledge is really valuable also outside of the bank, and started offering mobile security services and software to companies all around the globe. So even in the States, we were working with defense companies like Northrop Grumman, with financial institutions like Jefferies, and so on and so forth. And this knowledge that we received mostly as well through the relationship with these huge enterprises, the knowledge and contacts with the teams at Apple and at Google are not things that are so easy to replicate. And as I said, the foundation of this decentralized compute needs to be the security aspect. And that's basically where our expertise really lies in.
Got it. Where can we send people to find more about the product?
They can go on Acurast.com Also, that if they now are looking at this on YouTube, YouTube actually has a lot of videos from people posting their setups. That's the other thing, because the compute really needs to be real and is verified by the network. Also, people are very proud to show off their setups. So you see people with 400 devices with cracked screens that are just setting those up. If you look for Acurast in Google and in YouTube. Yeah.
And then when you think about kind of going forward, give me the like 30-second pitch on what is this going to look like 10 years from now?
Well, 10 years from now, it's going to be the largest compute network worldwide, period. Because there's no other way how you can achieve this scale. And this is basically the mission that we have in the team to really scale that to that level. I mean, at least this is the ambition, right? No one can really foresee the future, but this is what we're aiming for.
Amazing. I love ambition. The more ambitious you are, the better. Let's see if you guys can go do it. That's a tall task, right? It's hard. I don't know if you're going to be able to do it, but it's worthy to go try.
Yeah. Wish me luck.
Good luck. Let's see what happens. All right. Amazing. Thank you so much for taking the time to do this, and we'll definitely do it again in the future.
Thank you so much, Anthony.